Okay, welcome to my movie on force. When we're talking about physics, a force is defined as a push or a pull. You can see me in the picture below with the box. When I'm trying to push the box, there are two ways I can push it. I can move the box, I can push it or I can pull it. And as long as the force is unbalanced, pushing or pulling will result in motion. What I mean by unbalanced is, in the first picture of me with the box, there's nothing on the other side pushing back against me, so this will result in motion. That is an unbalanced force. In the second picture, you can see me over there pushing the box with a baby on the other side. Since I am stronger than the baby, I will be able to push the box. The baby unfortunately won't fare too well, but it's just a pretend stick figure baby anyway. This is also an unbalanced force. If you haven't already done so, can you please pause the movie and write down everything that's on this page. Now, in the bottom set of pictures, this is called a balanced force. A balanced force does not result in motion. So you can see I went around and collected some babies. They leave those lying around everywhere, you know. And I found that it took 3 babies to balance out my forces. I am about the same strength as 3 babies. When I push on the box does not move. It does not result in motion. Okay, looking at the back of item 2-20, you will see that we're talking about Newton's second law, which we already talked about a little. It is the force equals mass times acceleration law. And I've drawn you another triangle. And if you can make sure you've written all this down, by the way, this triangle uses force, mass, and acceleration. It's just like the triangle we used for speed, distance, and time, but this one is for force, mass, and acceleration. Next to the triangle, I've noted some units for you. You need to be sure to write that down. It's very important. Force is always measured in a unit called newtons. Mass is always measured in kilograms. And acceleration is always measured in meters per second squared. Now, you might be asking, well, what is a newton? Newton is named for Sir Isaac Newton, of course, and he gets to have a whole SI unit named after him. And what a newton is, if you can imagine 1 kilogram of mass, so something that weighs a kilogram, a newton is the amount of force needed to accelerate that 1 kilogram mass at a rate of 1 meter per second every second. So force is just measured in newtons, and we abbreviate newtons with just a capital N. Okay, looking at problem number 1, you will see that first thing you need to do is make sure you read the problem. I don't know why the formatting is so weird. What is the force required to accelerate a car at a rate of 2 meters per second squared if the car has a mass of 3,000 kilograms? So first thing you're going to do is find out what is your variable. What's the thing you're looking for? Well, you can see in the problem that it says, what is the force? Which means force is the thing you're trying to find. So you're going to make force your variable. So I'm going to put an F right here. Force is our variable. Then it asks us, we have to try to figure out what the mass is. And it tells us right here that the mass is 3,000 kilograms. So we're going to put in here 3,000 kilograms. Then it asks us for the acceleration. Acceleration is listed right here, and we know it's acceleration because it's labeled meters per second squared, is 2 meters per second squared. All right, now we have all our information. We need to go back to our triangle to try to figure out what the formula is we're supposed to use. So if you go back and look at your triangle, you can't see it in my screen, but you can see it on yours, that the formula we're going to need to use is, when we're looking at the triangle, is going to be force equals mass times acceleration. And that's because in the triangle, mass and acceleration are next to each other, and in math, when two things are next to each other, we multiply. So now all we have to do is substitute. I'm going to do this down at the bottom here. Force equals, our mass was 3,000 kilograms, 3,000 kilograms times our acceleration, which is 2 meters per second squared. And then when we multiply, our force is 6,000 And now we just need to know what to label it. So we go back to the top of your page where I told you what all the labels are, and we said force is always measured in newtons. Label it newtons. All right, going on to problem number 4. This one is actually missing a piece of information, and you're just going to have to take me at my word. We're going to learn about it next class. But all objects accelerate due to gravity at a rate of 9.8 meters per second squared. We're going to talk about that a lot next class, but just take my word for it on this one. It asks us, we're going to first go look in the problem and see what our variable is. It says, what is the mass? So mass is going to be our variable. And then when we're, oops, I wrote that in the wrong place. Oops, sorry about that. That's not here. Mass goes here. I don't know how to erase right now, so I'm just going to cross that out. Sorry. Our force is 147 newtons. So I'm going to have 147 newtons. Now, when I'm setting this up, you can see I'm looking for mass. So if you look at the triangle, mass is going to be force divided by acceleration. So all we have to do is substitute. Mass is going to be 147 newtons divided by 9.8 meters per second squared. I'm running out of room, but I can't solve all that, and I come up with 15. 147 divided by 9.8 is 15, and then all I need to do then to find our label is to look at our top of our page where we said we always label mass with kilograms. So your answer is 15 kilograms. All right, going on, we're going to look at problem number 5. Number 5 says, what is the mass of a truck if it produces a force of 14,000 newtons while accelerating at a rate of 5 meters per second squared? I can see I am not going to have enough space on this. Let's see if I can move this up a little bit so we have more space. Nope, apparently I can't. All right, let's see here. First thing we're going to need to do here is figure out what our variable is. It says, what is the mass? So m is going to be our variable. It gives us the force right here, 14,000 newtons. We know that's force because it's labeled in newtons. And then it also gives us the acceleration, 5 meters per second squared. Now we just have to look at our triangle and see, well, we're trying to find mass. So we see force is over acceleration. So we're going to, our formula is going to be mass equals force divided by acceleration. So mass equals 14,000 newtons divided by 5 meters per second squared. And when we divide that, we get mass equals 2,800. And then all we have to do is think to ourselves, well, what were we trying to find? We were trying to find mass. So we need to label this with kilograms. All right, hopefully this has been helpful for you. What you need to do now is go back. You saw I skipped around a little bit on the problems. You need to go back and make sure you've answered all the problems on the back of 2-20 and on the front of 2-21, and then check Blackboard to see what you need to do next. And I hope this was helpful.